direct and partial variation. So when we're looking at this, we're talking about graphs and how the variation in a graph actually applies to the situation. So if you get paid $15 an hour at your part-time job, the amount you get paid directly varies with time. If I work 0 hours, I get $0. If I work 1 hour, I get $15. If I work 2 hours, I get $30. 3 hours, $45, and so on. So if I were to look at this graph and we made every, let's say, box $5, so we'd have 0, and then let's just make on the bottom here our time. So we've got 1, 2, 3, and this is in hours. So hours, and that's time. Let's fix that. So we're going to call this down at the bottom time, and it's going to be in hours. Now on the side, we're going to have pay, and it is going to be in dollars. Okay, so we've got 15, 30, 45, and 60. So if we looked at this at 0, so I'll make the dots a little bigger. At 0, we make $0. At 1 hour, we make $15. At 2 hours, we make $30. At 3 hours, we make $45. Okay, and we can see that this is going up with a straight, we can see that this is going up with a straight line. So we can model this situation with a line, something like that. Let's try to get this line in there. Nice and straight right there. Okay, so we're modeling our situation. So what would the equation to represent this be? Well, we know that for the time work, so we could say like pay, but our pay is on the y-axis. So we don't actually want to say pay. So why don't we say y equals, so let's talk about y and x. Y equals, well, we know for every x, we get $15. So it's going to be 15 times x. So y equals 15x. So how much would you earn if you worked for 12 hours? Well, all we have to do is sub 12 in for x in our equation. So we'd have y equals 15 times 12. And all we have to do then is multiply 15 and 12. So we're going to get 180. Therefore, after 12 hours, you earn $180. Okay. Now we've got the second example. A taxi charges a $2 initial fee and then 50 cents per kilometer. So identify the fixed cost and the variable cost. Well, the fixed cost is a cost that doesn't change. So that's the initial fee in this case. So that's our fixed cost. It's never going to change no matter how far we go. The variable cost is going to be the 50 cents for every kilometer, because that's going to change with each kilometer. For example, if we go 0 kilometers, it still costs us $2. If we go 2 kilometers, it's going to cost us $3. 4 kilometers, it's going to cost us 4. 5 kilometers, or sorry, 6, I'm going up by 2's here just so I can go up by $1, is 5. 2 times 50 cents is going to give me an extra $1 plus the $2. So 0. So if we had cost on the y-axis and distance on the x, and this is in kilometers, we would have $2. Then we go 2 kilometers, we're going to have $3, and so on. It's going to look something like this. And I'm not going to use the line this time. I'm just going to freehand a straight line. but our trend would continue like that. Now the equation for this one, well, we're still using the y-axis, so we've got y equals. We know that our x's are changing by 50 cents each time, so 0.50x. But we always have that initial $2, so we have to put plus 2 at the end every time. And now if we look at our equation, if we plugged in 0, we'd get 2. If we plugged in 2, we would get 3, and so on. So if I have $12 in my wallet, what's the furthest I can go? Well, we're going to put 12 in for y, and then we're going to solve for x. So we're doing reverse BEDMAS. So we're going to subtract that 2 over. 12 minus 2 is 10. And now we have to divide by 0.5. So we get x is equal to 20. So therefore, 20 kilometers. Okay. What we're looking at in that second one was a partial or indirect variation. Okay. Well, our variation is always varying at the same rate. We don't have a direct variation to our answer because we also have that initial cost. So in words, when we're looking at this, there's no initial value for direct variation, and there is an initial value. So we'll write value. For partial or indirect. The graphs, direct variation will always start at 0, 0. Indirect or partial can start off of 0, 0. It can look something like either of those graphs. I guess direct could go down this way too. An example of direct variation, it will never have a value at the end. So it's going to have some value like 2x. Okay, it will never have, it would be plus 0. So it's never going to have anything at the end. We never actually write that plus 0 in. Indirect or partial would be like 2x plus 2 or some other value. This is something other than 0. So something other than 0. So looking at these, classify each of the following as direct, indirect, or neither. Well, we have to look, do they start at 0? So this first one, does it start at 0? No, so that's indirect. It's a straight line, doesn't start at 0. The middle one, it doesn't really start anywhere. It's not a straight line. It doesn't have a direct or indirect, so that's neither. Okay, we can't see the value. This one starts at 0, 0, so that's direct. Okay. Looking at this next question. So we have y directs or varies directly with x. When x is equal to 5, y is equal to 10. What is the constant of variation? Well, what that means is that if we have a point here at 0, 0, if I were to go to 5 and then I went to 10, I'm going to have another point. So the way we can find that is we can actually just divide this 10 by 5. 10 divided by 5 is going to give me 2. So our constant of variation is our difference in our y over our difference in our x, which in this case is just 10 over 5, which is equal to 2. We'll say constant of variation. Okay, we're going to change the words of that in our next note. What equation represents this situation then? Well, this is going to be y is equal to 2x. It changes by 2 each x. Okay, last one. Complete the table and then write an equation and graph the line that corresponds with this. Well, we could graph it first if we really wanted to. First, we can recognize that this is not direct because we have an initial value of 6. If I look here, I've got an initial value right there of 6. So I know my equation is going to have plus 6 at the end. Now, I'm changing each value by something, and it's going to be a constant number. From 6 to 9, I have 3. So in between here, I've gone up 1, so that's got to be 12. And then this one would be 18. Now this number's not 5, so I don't want you to put a 5 there. We're going to figure it out. But we found that our constant of variation here is 3. So our equation is y equals 3x plus 6. Now the last one has y is equal to 27. So let's figure it out. I'm going to just use a pencil or a crayon here. So we have 27 equals 3x plus 6. I need to minus that 6 over to get it to the other side because we want to solve for x. So we get 21 equals 3x. And then divide by 3, we get x equals 7. So I'll put our 7 in there. Now let's graph our graph, and then we're all done. So we're starting at 6, we've got a point. At 1 and 9, we've got a point. At 2 and 12, at 3 and 15, at 4, 18, and so on. And the graph's going to kind of look like that. I'm going to connect those dots, and I'm just going to put an arrow because that's going to continue on in this way forever. Here are some questions associated with this.